Good morning and welcome, everyone. My name is Aaron Griffin. I'm the commercial leader of the Americas for the Plastic Additive Strategic Business Unit of Milliken and Company. We have two guests here today going to speak on barrier of impact in high-density polyethylenes. Norman Ubi, he's a technical service fellow from Nova Chemicals, focused in the area of solid waste orientation and development of film structures. Please welcome Norman. And also we have Enrique Noguchi. He's the Global Technical Service Leader of the Plastic Additive Strategic Business Unit of Milliken Company. Please welcome Enrique.
Okay, good morning, everyone. So a quick introduction about Milliken in the beginning. So Milliken is a global company present in several different areas, textiles, floor covering, plastics additives, and chemical industry in general. We are globally located, like more than 70 locations, more than 7,000 associates, creating tens of thousands of products. We have a very strong commitment to sustainability and positive impact on the next generations that can be noted. Let me see if I can use this attribute here. See? By, pretty cool, right? By being one of the few companies that has been present in all the 19 lists of the most ethical companies by Ethisphere, by our gold standard on EcoVadis, by also being one of the first companies to have validated net zero targets by SBTI, and several other indicators. We are part of the plastics additives business, almost everybody that is present here, and we strongly believe in partnership. So we understand a lot about how to modify polymers, so how to modify the morphology of polyolefins, but there's a lot of things that we don't know about. And that's why we like to partner with customers and with partners in the value chain like Nova to find solutions for the market needs. So let me give you a little bit of context before jumping into like UltraGuard itself. So everybody knows here that plastic packaging, especially flexible plastic packaging, has been under a lot of scrutiny recently, right? So there's a lot of pressure around waste generation, sorting, collection, incorporation of PCR, actual recycling of those films. But despite all that, the estimated growth for plastic packaging, for flexible plastic packaging, is still higher than the average GDP growth in the world. So that indicates that it's still addressing a lot of the issues that we see from consumers. In this report here from BCG, for example, they identify 5 megatrends specific to the North America packaging industry, and their evaluation, like their assessment, is that flexible plastic packaging is one of the solutions that's going to emerge as the winner, that addresses all the different types of needs that the consumers have nowadays. Now, that doesn't mean that it's going to be easy, right? So there's a lot of challenges ahead of us. All the companies in the value chain in the last 7 to 8 years have spent a lot of time addressing all the low-hanging fruits. So all the problems that are left to resolve are the very complicated ones that we're not going to be able to fulfill by ourselves. And that's why we have to invest a lot of innovation and collaboration, like we have been doing with Nova Chemicals for a long time. Just to show an example, right? So I think most of you have seen like the recyclability guidelines from APR and from Recyclass. These are examples of hundreds of hours of people talking in the background, different members of the value chain, brands, converters, recyclers, additive producers, polymer producers, collaborating to find out a common guidance on how to make recycling better and more efficient. So UltraGuard is one of the solutions, one of the contributions that Milliken is bringing to that equation. So UltraGuard is a family of products for barrier improvement of polyethylene. So it can be used in linear low density, but mostly it has been used for high density polyethylene, which is the main polymer you use when you want high moisture barrier in films. It increases the barrier, so it makes the transmission rate lower, and that can be used in a variety of ways. That Norm is going to give some examples on his part of the presentation, but that can be used to improve the flexibility of design for converters that allows for thinner films or different materials used in each one of the layers, or improving the shelf life with better barrier in general. So there's a variety of ways that this property improvement can generate value improvements. We are on the second generation of the UltraGuard family. So this new generation of SKUs are bringing up to 20-25% improvement versus the previous generation, which was already much better barrier than any regular high density in the market. So this is an example of a product from one of the products of the new family, the UltraGuard Solutions 10523. It's available for sampling and for testing. Let me show you some numbers. So this chart here shows the OTR, so normalized oxygen transmission rates for several resins that we tested, both in cast film and blown film. And on the y-axis, you can see the improvement versus the past UltraGuard family. And here on the x-axis, you can see the reduction versus the control resin. So you see there's a lot of resins that even get past 25% improvement. Now, there's some resins that whose improvement is not that high, and I'm going to explain a little bit later what drives that. But regardless, you're still always having 40 to 70% in most of the cases of improvement versus the non-nucleated, just pure barefoot polyethylene grade. This is the same data, but just now with WVTR, so water vapor transmission rates. Usually the improvement rates track very closely. So if you get 25% improvement in OTR, you're almost certainly going to get the same transmission rate improvement in WVTR and any type of permeant, because the mechanism that UltraGuard uses is a passive barrier generation. So it's going to improve the barrier against fragrances, grease, oil, CO2, whatever you can imagine. Now, talking about the performance, right? So how can you get the best final results? If you look at the chart here on the right, there's two ways to get to the lowest point possible, right? So you have to either start from a lower transmission rate or have the lowest reduction, the biggest reduction possible. So there are a variety of ways to address that, but most of them related to the resin design. So if you want to start from a better point, you usually go to a higher density resin. And to maximize the reduction here, to maximize this arrow, so what improvement we're bringing versus the starting point, it has a lot to do with relaxation time. So this is very tied to long-chain branching, the amount of long-chain branching and the molecular weight of the resin. So there's a lot of know-how there that the resin producers can fine-tune to get the best resin grade. And Nova particularly has done probably the best job on finding the resin that has the best response and the best barrier performance in the market. I'm not going to go into too much detail of examples because Norm has some more detailed, interesting cases. But this is, for example, what you can use with better barrier. So the gray chart here is just a pure resin, and the orange one is with UltraGuard. So if you just keep the same thickness of the film, so if you keep like the 55 microns, you're just going to get better barrier. But you can instead reduce the thickness, like all the way to 35 microns, and have the same level of barrier. So just two quick examples of how that can be used to enable flexibility of design. Here are some case studies on flexibles, injection molding, and blow molding. Can be used in all the different sorts of plastic processing. In these three cases here, the converters were looking for down gauging. But like I mentioned before, you might be looking for something else. You might be looking for a different blend of resins or higher performance for better shelf life. There's hundreds of ways that the converters can use the benefit we're bringing. So now I'm going to pass the word to Norm, that's going to talk about how they are using that to bring solutions to the market.
Good morning. So I'm going to focus all this presentation on a new product that's kind of come out from our collaboration. The product is called HPX267. It uses the latest technology from Milliken for a nucleator. When we started the work, I think we were looking at a variety of new designs, and then we had to start looking at our resin. Do we need to tweak our resin design to maximize performance? And that's part of what the work was to do this. Product gets used in a lot of applications where you want moisture barriers, so a lot of different food packaging, but we actually find a big home for it as well in mono-material structures. There was mentioned barrier, but it also enhances stiffness and things like that. And when you're trying to make an all PE structure, going from maybe a PET polyethylene laminate, you need all the stiffness you can get from the polyethylene material. Generally, what we're seeing is about a 20% improvement in barrier performance over our previous generation. So I'll just kind of quickly talk about the previous generation, some of the products we have. So now our new top performer is the HPX. You can see from a moisture vapor transmission rate, 1.4 grams per 25 microns per meter squared. The product that it's outperforming is our HPS 167. That actually used the first generation Milliken nucleator. When we introduced it in the marketplace, it was in the order of 40% improvement over anything else that was in the market. It has been basically, I call it the benchmark in the industry for 15 years now, since we created it. You can see the moisture barrier numbers for that. Both of them are based off a 967 density, so it's a very high density material. What we produce is a bimodal molecular weight distribution. We're using single site catalyst, and we can control the different molecular weights, and the nucleator works really well with one of those modes. That's where we get a lot of the performance. We also have HPS 667, again using the first generation material. That one's designed more for cast film or even extrusion coating, extrusion lamination type applications. And the last grade we see here is 19C, which is more what I call a traditional mid-barrier performance type product. It's not nucleated. So we're going to go through a couple case studies. So one of the first markets when we developed 167 was actually for the cereal liner industry in North America, where moisture barrier is the most important property it delivers, and it just allows you to have shelf life. You can see here, generally depending on the package size, the gauge may change, but you can see the kind of difference between the 167 and the 267 material. Generally 15 to 20% improvement in moisture barrier. You might ask, well, why is the thicker gauge a little bit lower than the thinner gauge? And that has a lot to do what Enrique was talking about earlier about relaxation time, but also drawdowns. So if you stretch a material more, it has less opportunity to relax. You start to crystallize, you don't get the preferred orientation. So with the new product, at thinner gauges, it definitely performs better in that regard. Another market where we see a lot of use of the barrier high density is in the high barrier market, where people are using EVOH type structures where they want the oxygen barrier, but they're using 167 or the new HPX 267 on either side of it to enhance moisture barrier. And really what you're doing is protecting the EVOH from moisture ingress. This is kind of an interesting chart. This talks about blending traditional high density or non-nucleated high density with the HPX 267. Most people think when you blend, it's just going to be a linear change, so the red line. But that's not at all what we're seeing. We're seeing the blue line. You can see actual data points. And what that does is it creates opportunities for people. Maybe you don't need all the moisture barrier performance that the HPX 267 delivers. Maybe one application, but you have a whole bunch you don't. You can start to blend in a conventional high density, start to reduce your cost, but also maintain or have very good moisture barrier performance. So there's a real advantage to look at this as a blending solution as well. That also works in linear low, same type of trend. We don't necessarily see a lot of people doing that for moisture barrier, but we see it actually for oxygen. And granted, people don't think of polyethylene as its oxygen barrier, but usually it's about tailoring oxygen transmission rate. And you can see here by blending small amounts of the high density into the linear low, you can affect very significant changes. But if you look at the other end of this chart, putting small levels of linear low don't actually change your barrier performance that much. So you can actually potentially use some linear low to enhance the toughness of the high density material. Here's a case study for cereal liners. Really, it kind of talks about the supply chain and the kind of timelines people need for shelf life. Generally, I think they design these products for about 10 to 12 months, but the actual true shelf life is much shorter than that. Replacing a standard type structure with using the HPX, you can extend the shelf life greatly. I don't know if people need to do it, but what the other opportunity is, well then can I start to reduce costs, reduce gauge, improve the overall performance? And one way might be I start to incorporate some linear low into that structure, down gauge the high density, keep the overall gauge of the film the same, but now when I go to open that package, it doesn't want to explode on me. It's got more toughness and it will withstand more. I mentioned real quick using it to enhance or protect EVOH from moisture ingress. And that's another area we've seen the 167 and the HPX 267 being used. And EVOH, as it absorbs moisture, it starts to lose its oxygen barrier performance. And putting the 267, the HPX 267 on one side or the other side of the structure can enhance, protect it from getting a lot of moisture and just extends the performance of the EVOH. Structure designs to take advantage of this are kind of, you got to be a little careful designing. I've seen where people put barrier high density on both sides of EVOH thinking they're protecting it, but what really happens is from the wet side goes through, but then it doesn't want to go through the other barrier side, and now the EVOH is starting to get saturated and you actually lose performance. So you need to be very careful how you design those structures to take advantage of that.
So just to recap a little bit what we were saying, right? So we have been collaborating with Nova for a long time, and we believe that that brings a lot of value to address those very complicated problems that we have in the plastics industry, especially related to sustainability, recyclability, incorporation of PCR, keeping the same performance, right? We don't want to give up performance by achieving those goals. So that's the reason why we developed this new family of UltraGuard products. Like Norm was mentioning, there's several different ways to use it. If you have interested in testing, just get in contact with me or Norm, and we're going to help you with that. Yes.
Yeah. So on the enhanced product design, I talked about the shelf life extension. I think what we'll generally see is more, how can I down gauge the package? How can I reduce the cost? That's probably what we'll see more, but you have the opportunity to go either way on that. And then the elimination or reduction of non-PE layers. That one's a little bit of a trick. We've definitely been able to reduce certain types of materials, but you can't fully eliminate. But if you can reduce them enough so that now it's considered a recyclable structure, it opens up some opportunities for people. Good.
Thank you.
Thank you.
Thank you, gentlemen. Questions?
Just a simple processing question. At similar thickness, would you think there is an influence on bubble stability?
Between
the new grade and the traditional ones?
No, very good question. So if I compare it to the HPS 167, it's a 1.2 MI. The new product's a 2 MI. So yes, they're not going to have the same melt strength. So I think there are ways around it. You start adjusting processing temperatures to kind of bring some of that melt strength back. And really it comes down to the structure in which you put it in. You can usually use other materials to maintain that melt strength. Now, if it's the vast majority, you're right. I think you definitely need to look at adjusting melt temperatures to process the new material.
But the presence of the additive is not important in the equation of stability.
Bubble stability, no. Yeah.
Thank you.
Thanks again. Thank you, Norman. Thank you, Enrique.
Thank you.